Now we will understand the motor action, or the how does motor is behaving. That electricity supply is given and mechanical work done is there. Okay, to understand the motor action more, we can understand this using Fleming's left hand rule. Okay, so it is very important to remember that motor, Fleming's left hand rule; generator, Fleming's right hand rule. Okay, so I will give you a punchline with the help of you, which you can understand this and remember this for long. Okay, great role models loved by all. What happens in the motor? Since electricity supply is given, so the current carrying conductor produces a magnetic field, rotating magnetic field, which is around the conductor as shown in the figure, central figure B. Okay, and the first figure A is the uniform magnetic field, which is flowing from north pole to south pole. So this is the applied magnetic field, which is strong, and this is the rotating magnetic field, okay, due to conductor. So the magnetic lines of forces will be, say, moving in the clockwise direction. Okay, so this is this, but these rotor or the conductor and the magnetic field are not working alone, they are working in tandem. Okay, so practically what is happening, that this rotor is placed in this magnetic field, so the direction of the magnetic field, which is common, for example, so now this is the resultant, so the applied magnetic field was also moving from north pole to south pole, and this was also from the clockwise. So the magnetic lines of forces or the magnetic field strengthen here. Okay, and the magnetic lines of forces here was this direction, since we are calculating the clockwise direction. So here it is this, and here it is this. So it is strengthening the applied magnetic field, and it is weakening the magnetic lines of forces of the applied magnetic field. Okay, so we can say that it is like this. If here we are representing one line, then here are two line, then here it can be 3, 4, 5. Okay, so what will happen, it will push, since this conductor is on armature, so it will push the conductor from RHS to LHS. Net resultant will be from RHS to LHS. Okay, so this is the working principle of motor. The first finger will be field, middle finger will remain current, and the motion will be given by the thumb as shown here. Okay, so if you point the first finger downwards and thumb will be inwards, sorry, yes, the middle finger will be inwards, then the thumb will give the direction at which it is rotating. Okay, is this clear? If we are dealing with the lossless system, then the electrical energy will be fully converted into mechanical energy, and mechanical energy will be fully converted into electrical energy. Okay, so that is also shown here. For example, this electric energy is what? Vi is the power, E being the EMF, so it is Vi, and if you multiply by T, it gives the energy. This is electrical energy, so it is, and the mechanical energy is force into distance. force is equal to BIL, so BIL into D. So RHS is BIL into D, and when we talk of LHS, it is BLV. What is V? V is D by T, T and T cancel out, so it becomes BIL. So it means that the uh, electrical energy can be fully converted into mechanical energy and vice versa. Okay.